Securing enterprise AI is not about adding one magic control. It means designing layers that work together: identity, applications, data, cloud, workloads, and governance. In this course, you'll learn how to build AI systems that are powerful, auditable, and trusted. Here's the path we'll follow. We'll start with identity and secrets, then secure applications, APIs, data, and AI. From there, we'll protect cloud and workloads, and then connect everything through governance, architecture, and a capstone design. Think of AI security as a stack of decisions that build on each other. Identity comes first, because every action needs a trusted principal. Permissions then shape what applications, APIs, prompts, models, and data flows can do. Next, we protect the cloud, workloads, Kubernetes, GPUs, and pipelines those systems depend on. Governance ties the layers together, using monitoring and audit feedback to improve policy, design, and access over time. To get the most from this course, choose the path that matches your starting point, while tying each topic back to real architecture. If you're newer, move sequentially and protect the foundations. If you're intermediate, go deeper where your role needs it and review neighboring layers. If you're advanced, use the modules as a reference and challenge the capstone. After each module, sketch the design, question assumptions, apply controls, and review trade-offs. AI security starts with identity. Before we focus on prompts, models, or agents, we need to know who or what is acting, what it can access, and where trust changes hands. IAM becomes the control plane across users, services, APIs, datasets, tools, and workloads. In this topic, we'll trace identity flows, define boundaries, and see how weak permissions or missing controls can turn normal AI workflows into serious security risks. In AI environments, identity is no longer just employees signing into apps. Services, agents, models, pipelines, tools, and data stores all act on behalf of someone or something. IAM verifies the actor, applies policy, authorizes the resource and action, and creates an audit trail. When identities are over-permissioned or access paths are not governed, attackers can bypass stronger controls and turn legitimate AI capabilities into breach paths. Identity in AI is not one thing. A human analyst, a service account, an autonomous agent, and a training job all act as principals, but each creates different risks. Humans need role governance and review. Non-human identities need tight secrets and rotation. AI agents need boundaries on tools and actions. Training workloads need controlled data and compute access. For every category, ask 4 questions. Who owns it? What can it access? How is it credentialed? And how is it monitored? A useful way to think about IAM is as one simple question. Who is trying to do what? To which resource? Under what conditions? The who might be a person, service, API client, or AI agent. The resource might be data, a model endpoint, a prompt, a tool, or a vector index. Context adds judgment: risk, location, device, classification, workflow, or time. The decision is then allow, deny, step up, or log. Trust boundaries are the points where security assumptions stop being safe to inherit. A user token accepted by an app may not be enough for an API, an orchestration service, a model call, or a data lookup. At each crossing, make identity explicit, validate claims again, and translate permissions when needed. Pay special attention to orchestration, because it connects prompts, tools, models, and data. Document these crossings before designing access rules. An AI request is rarely handled by one identity. The user authenticates, and then the app and backend services call each other using their own service identities. At each handoff, the system should carry enough user context to enforce data access and create an audit trail. Delegation is the key control. The orchestrator, retrieval layer, model, and tools can act only within the user's permitted scope, even though services are doing the work. Authentication answers: who are you? A login may verify a person, service, or agent. Authorization answers: what are you allowed to do? It checks each action against a resource and policy. Delegation is where the risk increases. When an agent acts for a user, it must inherit only that user's permitted access, not the agent's full tool access. Without those boundaries, one valid identity can become many unauthorized actions. Think of an AI agent as a caller that can trigger many downstream capabilities. The risk is not just the prompt, but what the agent can reach afterward. Permissions need tight boundaries. Read only where possible, approved tools only, restricted models and data by purpose, and no administrative actions by default. When an action could change systems, expose sensitive data, or affect users, require stronger authentication, explicit approval, logging, or human review. IAM failures in AI are usually not exotic. They are familiar mistakes with a bigger blast radius. Over-permissioned users, services, or agents can reach prompts, datasets, indexes, and model endpoints they never needed. Shared accounts erase accountability. Static API keys turn one leak into long-term access. Weak workload identity leaves pipelines, containers, and model services hard to verify. The pattern is simple. Every human, service, and agent needs a clear identity, narrow permissions, short-lived credentials, and auditable actions. Before an AI system reaches production, treat IAM as a design review, not a configuration task. Identify every actor: users, services, agents, models, tools, and data stores. Then ask what each can do, under whose context, and with what approval. Secrets need clear ownership, rotation, and revocation. Make the full path auditable from prompt to model response to tool execution. If you cannot trace it, you cannot reliably secure it. You now have the foundation for IAM in AI architectures. Many identity types, explicit trust boundaries, clear identity flows, and least privilege delegation. Keep asking who or what is acting, what it can access, and why. Next, we'll build on that foundation with authentication, SSO, MFA, passwordless access, and federation.